So we just saw in the previous unit that if we're looking at the limit as xy tends to some point ab of some function f of xy, then if we want to check a horizontal approach, we would use a curve like a plus t b, so that at time 0 we pass through the point that we're interested in. Yeah, and then the limit of f of xy as we approach, well, y is actually held constant along this equal to b. So I'll just include that in the notation. And then this becomes the limit as t goes to 0 of f of c of t, or written slightly differently, the limit as t goes to 0 of f of a plus t b. So here's just a few different ways to write the same thing. And the key point is that by restricting to this curve, everything down here becomes constant except for x. So we've reduced it to a one variable problem, and we can look at what we know previously by limits. And then similarly, if we wanted to check the vertical approach, then we would use a and then b plus t. So we do our perturbation. You can think of the t as being some perturbation. We're wiggling around just one coordinate by a certain amount. That happens in the second coordinate, right? And so the main point from the last unit is that, sadly, so let me label this main point. Sadly, using just the horizontal perturbation and the vertical perturbation, so using the limit as you approach horizontally or the limit as you approach vertically, this just doesn't tell you much. But the good news is that this is not a class about continuity. This is a class much more about differentiability and about taking derivatives and doing integrals. And it turns out that horizontal and vertical approaches do tell us a lot about derivatives. In fact, if we know that f is continuous at a given point, a, b, and that then the horizontal and vertical derivatives that's not actually what they're called. They're actually called partial derivatives, and that's the subject of the next clip. But for now, I'll just be goofy and informal and call them horizontal and vertical derivatives. They tell us a lot. In fact, if we happen to know that f is differentiable at this point, then they tell us everything about how f is changing in any direction at this point.